So, yes, as we were looking at this graph, we will clearly see that as I am increasing the number of terms, all right, in the sum, and the sum is clearly converging to 1. And the value is constantly increasing and coming closer and closer and closer to 1. So therefore, when we have series of this nature where the sum of the series is coming closer to a certain value, then we say that these are converging geometric series. Now, not all geometric series converge. To determine which ones do, we need to have a look at the formula for the geometric series that we just had learned. So our formula is for the geometric series is Sn is equal to u1 1 minus r to the power of n over 1 minus r. Now we want to know what happens to Sn as n gets larger and larger. So we will have to focus on the term that we have in this formula, which is of an important aspect is nothing but r to the power of n. Now, with most numbers, when we raise the number to a larger power, the result will always be bigger, right? So, for example, if I am talking about, let's say, 1.2 to the power of 20, the answer is going to be 38.3. If I say 1.2 to the power of 30, it is going to be 237. So you will see that the value is constantly increasing. But let's say if I am talking about the values of r, which would be between -1 and 1. For example, if I take the value as 0.2, okay, 0.2 to the power of 2 is going to be 0.04. If I say 0.2 to the power of 3, it is going to be 0.008. And let's say if I just go ahead and say ask for 0.2 to the power of 20, then it is going to give me 1.05 into 10 to the power of -14. Now, what does this indicate to us? That when the value of r is between -1 and 1, as n is increasing, the value of Sn is coming closer and closer to the value of u1 over 1 minus r. Why is this happening? Because this r to the power of n is becoming smaller and smaller and smaller to a point that this whole term is non-existent. Is coming very, very closer to 1. And therefore, when we look at it and relook at our formula, we can say that when a series is a converging series, then I can go ahead and find out the sum of this series to infinity with the help of the formula S infinity is equal to u1 over 1 minus r. Now it is very, very important for you to understand that the value of r will have to be between -1 and 1. It cannot be even equal to -1 or equal to 1. Equal to 1, of course, we do know that the geometric series will diverge. But when we have r is equal to -1, there is an ambiguity in mathematics. It's very interesting that ambiguity in mathematics is something that we usually or rarely see. But yes, when r is equal to -1, there is an ambiguous nature of the series where you could have certain series that are converging while there could be some series that are diverging. That's the reason the formula will not be applicable at all times when we say r is equal to 1. Therefore, this particular formula that we are talking about will only be applicable when it is between r is between -1 and 1. So just to repeat, when you have a geometric series that is converging in nature, we will go ahead and find the sum of infinity of this series, because we know that it is converging to a certain value. The sum is converging to a clear value. It is not divergent. And when we are going to find out the sum of this series, you can use this formula to go ahead and find the sum of infinity of this series. So let's take an example and see if we've understood the whole concept here. So the question here is, the sum to infinity of a geometric sequence is 5. We have been given that the second term is -6 over 5, and we are expected to find the common ratio here. Now, in terms of the information that's been given, all right, I can clearly see that it says that sum to infinity. Therefore, I'm going to use the formula of sum to infinity, that is equal to u1 minus 1 minus r, which they say is equal to 5. I do also see that the second term has been given to me. Now, since the second term has been given to me, I can write u2 is equal to u1, r to the power of 2 minus 1 is definitely r, and that is given to me as -6 by 5. So now, using this, we are going to go ahead and we will see that we can just manipulate this equation, and we can find that u1 in terms of r is nothing but -6 by 5r, right? Now I'm going to go ahead and substitute this in this equation that I have here. And when I go ahead and substitute this, it is going to be -6 over 5r into 1 minus r is equal to 5. We go ahead and simplify this. We are going to get -6 is equal to 25 r minus r square. After this, I'm going to go ahead and further simplify this. I will take the -6 to the other side and also make sure that it is in terms of a quadratic equation. So it is 25r square minus 25r minus 6 is equal to 0. Now once you've got this, we'll go ahead and then factorize it. And when we factorize this, it is going to be 5r minus 6. And yes, the other term that I'm going to see is 5r plus 1 is equal to 0. Now you do know how to go ahead and solve these terms to be able to find the value of r. So our r is going to be 6 over 5 or -1 over 5. Now what is important here for us to understand, that we need to know that this geometric series will only be applicable, the geometric series will only be converging when the value of r is between -1 and 1. Now if I see this value here that has been given, this one is definitely more than 1, and therefore we reject this value and we will take this value here, and therefore this value of r, the answer to this question is -1 by 5. So it's very important for you to find out, based on the conditions of a converging series, as to what the value of r is applicable and reject the other value to get this. So I hope you've understood, and then we'll move on to the rest of our problem solving questions and understand it further.